So any interface from Java 1.8 onwards, any interface that has got one single abstract function declared in it is a functional interface anyways. Whether you have that annotation put over here or not, that's a different thing. But though, if I mean, I can very well put the annotation here, at the rate functional interface annotation here. This at the rate functional interface annotation is as same as your at the rate override kind of annotation. It helps you to just simply make sure that you have not unintentionally violated, you wanted to override a function, so the name of the function must be exactly and the signature must be same as the one that is there in the super class. So if at all you have unintentionally, if you have given any other name, then in that case at the rate override will complain saying that okay, you're saying at the rate override, but then the name of the function is not same. Similarly here, at the rate functional interface, if at all I end up defining intentionally or unintentionally here in this case, okay, if I define any method over here, which is, so now this tax calculator has got more than one abstract function, in such a case it ceases to be a functional interface. And you see, just because I have given a annotation here, it will complain saying that this is not a functional interface. If I remove this, yes, it compiles successfully, but in any case, even if it successfully compiles, it doesn't mean that it is now still a function. It's not a functional interface in any ways, right? So a functional interface is the one that has got only one single function declared in it. This is very important, okay? Understand this. And then uh, okay, and then the next is this. I have okay, just a minute. Yeah. So here you are. Now what I'm going to do is I'm going to remove this, so it is definitely a functional interface now. And see, this is after all an interface, and we have been doing this since ages, right? In Java programming language, that whenever we know that we have got a inline implementation of an interface, inline implementation, what does that mean is I create an anonymous class, and that anonymous class ends up implementing a given interface. Why? Because why do I create anonymous classes? So that just because I do not want to reuse the implementation of that anonymous class anywhere else in my entire application, so it makes no sense for me to go on creating different .java files. So if something like tax calculator, I can very well say tax calculator, I'll say t is equal to, and I'll say, see, I'm creating an anonymous class over here. I'll say new tax calculator. This tax calculator is actually an interface. But when I say new tax calculator, I end up creating an anonymous class implementing this interface tax calculator, and here goes the implementation of calculating the tax, right? I'll write system.out.println calculating tax. Okay, this is what I have. As simple as this. Okay, now point here is from Java 1.8 onwards, the implementation of a functional interface, not all the interfaces. And of course, not all the interfaces are functional interfaces in Java. There are so many interfaces. For example, you've got an interface called rowset. Okay, there are so many, hundreds of them. Rowset. This interface is not a functional interface at all. There are several functions. See, these many are the, all of these are the functions in that rowset, right? I've got result set. I say result set. Okay, result set is not a functional interface. There are so many functions defined in that result set as well. There are hundreds of such interfaces which are not functional interfaces. They do not represent one single functionality at all. They do not represent one single functionality at all. They represent the set of services. I am saying set of services. That means not one but many services are declared on the face of that interface. That interface represents the API. Correct? Whereas this kind of interface, which has got only one single function declared in it, that does not represent the API, that represents a functionality, right? That represents a functionality, a given functionality, one single functionality. In this case, it is calculate tax. Correct? So there cannot be more than one interface. I'm sorry, more than one function declared, abstract function declared in a functional interface. Okay. Going forward over here. Take a look. Now I'll say tax calculator. I'll say T2 is equal to tax calculator. I'll say T2 is equal to, see what I'm doing here. Instead of providing this implementation, right, as an anonymous class, I can provide the implementation of this calculate tax as a Lambda expression. Just that, please make note of the signature of this function here that is declared in this interface. Calculate tax. It does not take any argument. It does not return anything. Okay, in such a case, take a look. I will just open and close bracket because it does not take any argument and it does not return anything. I'll just open and close bracket over here. That's it. See, it compiled successfully. I could have given here any executable statements. I can write system.out.println. I'll say in calculating tax. Okay, this is the implementation that I have given. This is the inline implementation, correct? See, as simple as this. But if at all this is a not if this is not a functional interface, for example, I'll say public void, okay, I'll say calculate state wise tax. Suppose this is what I have. Now in this case, this interface is just perfect. It's an API kind of an interface. It does not represent one single functionality. If that is the case, here in case of an anonymous class, I can very well get away with having the implementation of that second function as well. So this works fine, but here this is not possible at all. Why? Because the Lambda expression here, your Java runtime environment, forget about runtime, even your compilation will get confused, saying that this is actually the implementation of which one of the two. Is it the implementation of calculate tax or calculate state-wise tax? Well, and that's not how it works. You must, if at all you want to use a Lambda expression, it must be of an interface. That means Lambda expression can be used in order to provide the implementation of a functional interface which is actually a functional interface which has got one single function in it, one single function declared in it. Now what I can do is, just for the sake of your additional inputs over here, see, I can very well do here default, I can put here, and I can open and close bracket here, and I may write some piece of code over here. Now this is still a functional interface. Why? Because abstract function is still only one. This is the default implementation. This again was added new in Java 1.8. Otherwise, until 1.7, you cannot have any default implementation of any method in an interface at all, right? So this is the beauty that you have over here. And then so this compiles successfully. Why? Because it understands there is one single abstract function here in tax calculator, and needless to say, in that case, this will be the implementation of that abstract function itself called calculate tax. You got that? You don't have to name calculate tax or anything, because you don't have to name. Why? Because there is only one. It understands. It does the inference, right? Automatically. It infers automatically over here. So this is how it is. Now I will go on putting few more things here step by step. So let me remove this here, and then I will continue with this. Please see. What if this accepts an argument of type integer? So I'll say integer tax rate. Something like this. Tax rate. Now what I'm going to do here is I go here, but then you see this gives me a compilation error. Why? Because there is actually a parameter that is sent to this particular function calculate tax, and this Lambda expression which represents this function in the functional interface did not take an argument. So I'll say X. It compiles successfully. What does this X? This can be anything like X or anything like I can say tax rate itself. So this tax rate actually now is nothing but the parameter that is passed as a, so you see tax calculator T2 is equal to, this is the implementation that I have provided. Okay, I could have given here very well calculating tax with rate. Okay, and then I'll say plus, I'll say tax rate. Okay, right? Or else I'll just simply say X and I'll give an X over here, right? See, this is how it works. Simple. Correct. So this is called kind of a this kind of a function in a functional interface is known as a consumer. Why consumer? It the implementation simply consumes the value. It does not return a value. You can see, is it returning a value? No. Correct. I will comment this now, and I will write a public void, and I'll say integer. Okay, and here I do not take any parameter at all. In such a case, I will not be able to pass a parameter, and I will have to return some of the other value here. And I'll say for now, I'll say just simply it returns an integer, it says. So I'll just hardcode the value 5 and return it. See, it compiles successfully. Such functions or such functional interfaces are known as suppliers. Why supplier? This is a consumer. It consumes the value. Okay, this is a supplier that supplies the value. It returns the value back to it, supplies the value. Very simple stuff. Cakewalk. This supplies the value to you, right? This is a supplier. Similarly, I can have, again I will comment this, I can have public integer, or I'll say void. I'll say calculate tax in brackets. I'll say string. I'll say integer tax rate. Okay, comma, I'll say string state, for which state the tax will be calculated, right? So this is how it is. In this case, this is a by consumer. By, why? Because there are two. See this two. This was just a consumer. This is a by consumer. So I'll say x comma y. Okay. Now it is a consumer. It does not return a value. See, it's a void. Hence, it was giving me an error. Now no errors at all. I can print the value of x, and also I can print the value of y. I can print the value of y as well. What is x? X is tax rate. What is y? Y represents the state. As simple as this. By consumer. Such interfaces, such functional interfaces are known as by consumers. Okay, by consumer. Then I may have something like this. I'll say public integer. I'll say calculate tax. I say calculate tax, and then here I'll say integer. I'll say tax rate, something like this. Now you see this. This is taking a parameter and also returning a value. I repeat, this is taking a parameter as well as returning a value. In such a case, again, it gives me a compilation error. Why? Because my lambda expression simply does not match with the signature of that functional interface. So what I'm going to do here is it takes one single argument and it returns a value. So what is it returning? It's returning an integer. What it is taking as a parameter, an integer. So I'm returning an integer from here, and this x will also be an integer. Okay, no y, no question of y, because it's not a by consumer. I'll just put x over here. Such interfaces are known as function. Java, just simply, it's a function. Simply a function. Okay, and then take a look at this. I may have something like this. I say a public, it returns an integer, it takes an integer, and also it takes a it takes the state, right? Now what is this? It is taking two parameters. I'll say by, and it is returning a value. It's a function. So this is a by function. Very simple. This is a by function. So here I'll say x comma y. It returns an integer. It compiles successfully. Yeah, it must write x and y. Sorry, what's the problem? Expression must be a functional interface. Yes, it is. X comma y. Oh yeah, I'm so sorry, I didn't comment this. So that ceases to be a functional interface. Now you see this, it compiles successfully, and I have my by function over here. See, these are what, this is how you create lambda expressions in order to simply represent the implementation of the functional interface. Just make sure, very simple, just make sure what you accept as a parameter, it is either unary or else it is by, it accepts one value. Okay, if it does not return a value, it's just a consumer. If it only returns a value and nothing over here, no parameter, it's a supplier. But if it takes a value and returns a value, it's a function. If it takes two values and return one value, of course return will always be one value. If at all there is a return value, then it will be only one. So in such a case, this is a by function, right? If it takes two values and returns nothing, then it's actually a by consumer. Consumer only takes value, does not return. Supplier doesn't take value, only returns the value. Function takes the value, returns the value. Okay, that's how it is. As simple as this. So now what I'm going to do is, I will help you to first of all get the source code. I want you to go through whatever I've explained here. I will help you to get the source code right there on your own machine. And then see what I'm doing over here. In Java, java.util.function. I repeat, in the package java.util.function. You can see this here, java.util.function. I am writing some, these are all functional interfaces. These are all functional interfaces. You see, java.util.function. You can see, what is this? This is actually a functional interface. What is the name of that one single method? Apply. So you got to see the signature of this, and it is with the generic type. Okay, T is the input. You can see this TT, and R is the output. So the data type is R. Now I'm going to write like this: function. I'll say string comma integer. What does this mean? You have got, I'll say f1 is equal to null. You are supposed to write the write on the right hand side. Okay, java.util.function.function. On the right hand side, you are supposed to write the lambda expression which will match the the signature of this functional interface. So here you must write a lambda expression for me. Note that what is the input, string, and what is the output going out, integer. How do I get that? From the declaration of that functional interface itself. You can see this t, that's the input, r, that's the output. Right, this is what I will very quickly write the other stuff also. I'll say by function. Okay, in case of a by function, I say it takes a string, and returns an integer. Okay, I'll say f2. You are supposed to give me an expression on the right hand side, a valid expression. I'll write by consumer. Okay, this is again from java.util.function. I'll write string, and I'll write string. Now you say f3 is equal to null. I want you to give me the expression on the right hand side. I'll write supplier. Okay, supplier, and here okay, supplier, and here I'll say a string. Okay, so I'll say f4. You tell me what will be the right a valid expression over here, java.util.function.supplier. Okay, then finally I'll say long stream. Okay, and you see this I'll say f5. This is actually also a functional interface. You figure out what must be the right kind of expression here, and then function by consumer, that's okay. And then I have let me take just another example here. Okay, unary operator, and also of type integer. You've got to always get to the source code here, and you've got to find out what it is. Okay, you've got to get to the source code, see it extends from function t comma t. You must be able to figure it out, and I'll say f5 is equal to null. This is what you are supposed to do, my dear friends, right? Sorry, f5 is already taken, so I'll say f6. I want you to write these expressions here on the right hand side, right, friends? Try and understand. So whenever you want to work with any one of these functional interfaces, you've got to see the abstract function declared in that functional interface. What is that abstract function? What is the signature of that abstract function, along with the generics, along with the type that is declared for that functional interface. So here you see this is the functional interface which takes two types, t and r, and the t is actually supposed to be input and r is the output. So similarly here, when I say function string comma integer f1, what does this mean? That it will take an input of type string and return back an integer. Okay, you are unable to connect to the voice. Back here. So function, it's a functional interface, and there are two types. One is the input and the other is the output. So I will write an expression like this, any expression which conforms to the interface. I'll say x, this is the input, right? And what is the output? It must be an integer. I can hard code a value here, or else I'll say x dot length or whatever. Just you've got to make sure that I return an integer. Okay, so see, this is how you write your lambda expressions. If at all you want to write multiple lines, then in that case you will have to open bracket and close brackets here, and then you will have to put something like this with a return statement. Okay, and then if you want, you can write some few more lines over here. Okay, maybe one line, maybe more than one line, but otherwise you can always just simply say x dot length, wherein you just need to put a semicolon here. You don't need to open and close bracket at all. Okay, and then you've got a by function, my dear friends. Take a look at this by function here. This by function is what? Again, it's a kind of a function, right? But then, so if it's a function, it will definitely return a value, but then by means it will take two inputs. Again, when I control click over here, you can see this t, u, and r. You can see this t, t, u, u. These are the two parameters, t and u. So the first type is the first input, second type is the second input, and r represents the output. So here I go, I'll say brackets. Now see, here I don't need a bracket. The reason is that there is only one parameter. But if there are more than one parameters, then I better use a bracket, x and y, and then so x is the first input, y is the second input, and what I want to return back is against an integer. I could have hard coded the integer here, or else I'll say x dot length. Okay, x dot length here plus I'll say y dot length. Okay, so this gives me the addition of the length of both the strings that are passed as a parameter. Well, I don't think it makes any sense in real life, but then still, just for sake of getting the lambda expression written over here. And then you have by consumer. See, consumer, there is a typical thing about a consumer. It gives you a value it does not return, it's a void, it never returns a value. In case of a supplier, it does not give you the value, it is expecting a value to be returned back. See, by consumer, take a look at this. Accept tu is just simply acceptance. Okay, so I will go back over here, null, and instead of null I will say x and y. These are the two values that would be consumed in my statement here, whatever that statements are, maybe one line of code or maybe 10 lines of code. Then you've got a supplier here. What is the kind of what kind of a supplier is this? It is supposed to return a value. What value? Of that, of data type string. Take a look, t get, you can see this, whatever is the first type, that is the return value here. So what I'm going to do here is I'll say, okay, in case of in case of one parameters, no parenthesis needed. In case of two parameters, parenthesis is needed. Also in case of no parameters, parenthesis is needed, saying that there are no parameters. And what I return back is any string. Okay, this is what it is, right? And then I go back over here. I'm back here, long stream. Now see, this is a specific type. When I click on long string over here, and you can see this, a stream. It's a long stream. Well, the name of the abstract function is supposed to be. No, I'm sorry. Here, you know what? It's definitely a it's okay. Sorry, I'm so sorry, I got it wrong. This is not a functional interface at all in the very first place, so leave that aside for a moment. Now unary operator here, unary operator. So I've got integer here, integer, correct? And this, wait a minute, long stream. It was a stream, correct? It was a stream. I'm so sorry. It was a stream, and it's not a functional interface at all. So unary operator, when I say unary operator, it works on one single value, and it is going to see this, return a value as well as accept a value. So you see this, it extends from a function. When it extends from a function, both are t comma t. That means input is t and the output is also of the same data type. And what is the data type over here? Integer. So I'll say x and I'll say x plus 1. I'm expecting an integer and returning back an integer. Unary operator is actually of what type? Function, wherein the data type of the input and the output is both exactly the same. You see, function tnr, but there it is tt, so it's exactly the same. You see, that's how it is. Okay, so unary operator. Predicate, very, very useful, used very extensively. Predicate is actually something which helps you to return a boolean. So it's standard, it will always return a boolean, but it expects an argument of what type. Here I have specified type is string. You can see this here, predicate, and I've got t, and this t is the data type which is passed as a parameter. So I'll say x, and I'll say x dot, if it is a string, I'll say contains, and I'll say well, whether it contains IBM. That's how it is. So predicate is, this is how it is. So these are the representation of, or these are the Lambda expressions for the respective functional interfaces. You will come across many such places while working with streams, while working with flux and mono. You will come across a lot many operators. I repeat, you will come across a lot many operators on flux, those that take functional interfaces, the Lambda expressions as a parameter, or I can say functional interfaces as a parameter, right? So hence you must be pretty comfortable with this, but don't worry about it. As you keep on working on this day by day, you will realize that you are becoming expert on this each day as you go on using them.